And welcome. We're going to go over this problem today, longest substring without repeating characters. And so this is the problem description. Given a string S, find the length of the longest substring without repeating characters. So we first are going to enter the UMPIRE process to go about understanding this problem. So we first understand that the input is a string S and the output is longest substring without repeating characters. Okay, so now let's look at some examples. So if we have the string ABC, ABC, C, or BB, we see that the answer is going to be ABC with the length of 3. So if you check for any longer subsequences, it's going to repeat. So ABC A repeats, and so this other substring ABCB B repeats. So it's not going to be longer than uh, th 3 letters. So in this example 2 of a sequence of letters B, 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 the answer is going to be 1, primarily because B is a substring that doesn't repeat, or the longest one that doesn't repeat. And so in example 3, we have PWWKEW. So if we check for the longest substring here, that with no repeats, we have either KEW or WKE. So that's the length 3. So the substring is going to be of length 3, the longest substring without repeats. Okay, so now that we have an understanding of this problem and what examples go into it, so now let's smash this problem. So the similar problems here are other substring problems where we have to deal with string manipulation. And we have to go through at least a single loop to go through the substring once, and it's to find its beginning and end substring components to find the largest substring without repeats. And then we probably have to use some selection statements to, or maybe we don't need selection here. So just the loop. So now we want to plan this. So what we want to do is initialize last index array with 256 elements to -1. So just so we're extracting the last element of so that's just the last index of any string. So the reason why we want 256 elements is because we want to index each element of any characters that we could possibly see. So that's all the ASCII characters. And so we want that so that we can have a map to actually determine the the um, the index of the in which we put the substring character and the last index. And then we want to update window in which we calculate the window size of non-repeating characters in sequence. So now that we have a plan for this problem, let's go ahead and implement it. So we want a last index array. So this is -1. And then we want the first index to be equal to 0, then the result is equal to 0. And then for j in range with s, so we're looking at the last index j. We want the first index is going to be equal to the maximum of I, the last index order si plus 1. And then the result is going to be the max of the result, or j minus I plus 1. And then the last index we have to update, which is going to be the order as j. So this is j is equal to j. So that's the solution. So we have a return key of res. So that's the solution. Okay, so we have a solution. So now let's step through the review of this problem. So we want to go through and print this longest substring function. And so we first initialize the array of the ASCII characters to last index, and then we initialize the first index and the result. And we're going to range over the last index, which is we update I, and we update the results, then we update the last index, and then we go through each character in the string, and then at the end we return the result, which is going to be 3, given that the input is ABC, ABC, B. Okay. Now that we have a review of this problem, now let's evaluate. So the evaluation is the time complexity is going to be of n, since we only run through one for loop over the length of s, and then space complexity is going to be O of n, since we had to initialize a last index array. Okay, so that is it for today. Thanks for listening.